We got cut off just a little bit there, but I was just talking about this problem right here, where if you have a high coefficient of determination, does that imply a causal relationship? And of course, a high coefficient of determination goes along hand in hand with a high correlation coefficient, because it's just the square of the correlation coefficient. And so the answer to this is a big fat no, right? A high coefficient of determination merely indicates that there is a strong relationship between the the variability of the two variables, but it is almost always not causal due to lurking variables, right? There are other things going on that affect your weight, right? For example, so even if you had a high R squared, well, even if you had a high R squared, first of all, it doesn't mean that the bit that you've got is being caused by your height. It could be other factors that are going into it as well. And then second of all, there are still other things that would have an effect on what's going on. Okay. All right, so let's look again at the relationship between fertility rates and life expectancy. So here they are. Now, you remember when we did this, and I'm just going to remind you, actually, I'll talk about this later. Hold on. When I make a scatter plot with Excel, I have the option of turning on the equation. We used that in the previous section to find the equation. And then I had the option of turning on R squared. So it's right there. They're giving you R squared. So down here it's saying, how could you compute it? Well, our Excel just kind of finds it for you, right? 0.5803, right there. So it's just given to you in the graph and gave it in the scatter plot. All right, interpret that coefficient of determination in the context of the situation. So what it means is that 58% of the variability in life expectancy for people in 1962, right, the up and down of life expectancy, why these blue dots are low and some blue dots are high, can be explained by that black least squares regression line. Or you could say by the variability in fertility rate. That would also work, right? Which means the complement would be unexplained, right? So 41.87%, I think I'm doing it in my head, is left unexplained. All right, now be careful about what this means. I'm not saying that 58% of why you lived the age you live is explained by the line. That's not what I'm talking about. I'm saying, okay, 58% of the variability, the up and downedness of this can be explained by the line. It doesn't mean that the line's causing it. It doesn't mean that fertility rate causes these things. It means that there's a relationship going on. And fertility rates and births per woman has a whole bunch of lurking variables into itself, right? And all of those variables that affect fertility rate are also affecting life expectancy. It doesn't mean that fertility rate causes the life expectancy. It means they have a lot of things in common, right? You don't get to see what those are, but you know how much percentage-wise it accounts for. All right, now what about the math test data from Ohio? How could we find the coefficient of determination ourselves if we weren't given a lovely Excel graph? Okay, well, remember, we've worked with this data set before, so I can copy and paste it into StatCrunch, remember? And then I can go to Stat, Regression, Simple Linear. This is the exact same stuff we did before in order to find the equation. That's my X, that's my Y. Just skip all that. Don't need any of that. At least not yet. Do you want to plot the line? Yes or no? That's up to you, etc. Calculate. And it gives it to you. R squared is right there, 0.473. If you copy and paste it into Excel, which we already did way back in the day, it was right here, and you can see it. There it is. R squared was 0.473. Now, if you're in Excel, you have a couple options. You can insert a scatter plot. And then remember, you can right-click on the dots, add a trend line, and then down here, display R squared on the chart right there, right? That's how you can get it, 0.4732. Or, which we also, by the way, already did way back. Here it is, right over here. Or you can do the data. So if you have data analysis turned on, you can go to data analysis, go to regression, say okay. Remember, regression goes backwards. So you go Y variable first, then X variable, etc., etc., etc. Click on your labels thing, put where you want to put it in the thing, and say okay, whatever. I'm canceling because I've already done it. It's right over here. And it came out, and right there, the second thing was the R squared.